Hello dear students, Assalamu alaikum. I hope you will be fine. My name is Engineer Mir Masood Shah. I am lecturer in Department of Technology, Saurabh University of Science and Information Technology, Peshawar. As I am teaching you the subject Fluid Mechanics, today is your lecture number 10. In lecture number 10, we will solve some problem related to Bernoulli's equation. So coming to examples, we have example 7.4. The statement is the diameter of a pipe changes from 200 mm at a section 5 meters above datum to 50 mm at a section 3 meters above the datum. The pressure of water at first section is 500 kilopascal. If the velocity of flow at the first section is 1 meter per second, determine the intensity of pressure at the second section. So we have a pipe whose diameter at one point is 200 mm and the height or that section is 5 meter above the datum, while the other section is the other side of the pipe is 550 mm and that section or that part is 3 meter above the datum. The pressure of water at the first section is 500 kilopascal and also the velocity at the first section is given, which is 1 meter per second. We have to find the intensity of pressure at the second section. So first of all, we will write the given data. In given data we have diameter d1 is given, which is the diameter of the pipe at first section, which is 200 mm. Divide this 200 mm by 1000, you will get this value d1 in meter, which is equal to 0.2 meter. Z1 is already given, which is 5 meter. D2 is 50 mm. Divide this by 1000, you will get this 50 mm in 1000, which is equal to D2 is equal to 0.05 meter, and Z2 is equal to 3 meter already given. The pressure at point 1 P or first section P is equal to 500 kilopascal, and that is equal to 500 kilonewton per square meter already given, and also the velocity at the first section is already given, which is 1 meter per second. So let V2 is equal to velocity of flow at the second section and P2 is equal to pressure at the second section or section 2. Now we know that the area of the pipe at section 1 A1 is equal to pi by 4 d1 square using the area of circle. So we have already the value of d1. Put the value of d1, you will get the value of A1, which is equal to 31.42 into 10 to the power minus 3 square meter. Now the area of pipe at section 2 A2 is equal to pi by 4 d2 square. Put the value of d2 and you will get the value at the area of pipe at section 2, which is equal to 1.964 into 10 to the power minus 3 square meter. Now since the discharge through the pipe is continuous, therefore using the equation of continuity, A1 V1 is equal to A2 V2. Now from this equation find the value of V2. As we have already find out the value of A1 and A2 and V1 is already given, so put the values, you will get the value of V2, which is equal to 16 meter per second. This is the figure of the example. This is the first section. The diameter of the pipe is 200 mm and the height from datum is 5 meters. Similarly, the second section is the diameter of the second section is 50 mm and the height is 3 meter from the datum line. Now applying the Bernoulli's equation for both the ends of the pipe, as we know Bernoulli's equation is Z1 plus V1 square divided by 2G plus P1 divided by omega is equal to Z2 plus V2 square divided by 2G plus P2 divided by omega. Now all the values are given or some of the values we have already find out. So put the values and find the value of P2. Z1 is already given, which is 5 meter. P1 is already find out, which is 1. G value is 9.81. P1 is already given 500 and omega is 9.81 since the liquid is water. So the unit weight of water is 9.81. Z2 is already given 3. P2 is already find out 16 meter per second. G is 9.81 and again W is 9.81. P2 is unknown, so solve this equation for P2. You will get the value of P2, which is equal to 392.4 kilonewton per square meter or 392.4 kilopascal. And this is the answer of our example 7.4. Now we have the next example 7.5. The statement of the example is a pipe 300 meters long has a slope of 1 in 100 and tapers from 1 meter diameter at the higher end to 0.5 meter at the lower end. The quantity of water flowing is 900 liters per second. If the pressure at the higher end is 70 kilopascal, find the pressure at the lower end. So we have a pipe which is 300 meter long. The length is already given. Also the slope is given, which is 1 in 100. The top diameter of the pipe is 1 meter, or the higher diameter of the pipe is 1 meter already given, and the lower end diameter is 0.5 meter already given. Also the discharge through the pipe is given, and the liquid is water, and the discharge is 900 liters per second. If the pressure at the higher end 70 kilopascal, pressure at the higher end is also given, which is 70 kilopascal. We have to find the pressure at the lower end. So first of all, in solution we write the given data. In given data, length is given, which is equal to 300 meter. Slope is given 1 in 100. d2 is given 1 meter, this is d1 is given 0.5 meter. Discharge Q is equal to 900 liters per second, that is equal to 0.9 cubic meter per second, and V2 is already given, which is 70 kilopascal, that is equal to 70 kilonewton per square meter. So let P1 is equal to pressure at section 1. Now we know that the area of the pipe at section 1 is equal to pi by 4 d1 square, so d1 is equal to 0.5. Put the value, you will get the value of area of the pipe at section 1, which is equal to 0.1964 square meter. Also the area of the pipe at section 2, A2 is equal to pi by 4 d2 square. Put the value of d2, you will get the area of A2, which is equal to 0.7854 square meter. Now first of all, let us assume that the datum line to coincide with the center of the pipe at section 1 as shown in figure. So thus Z1 is equal to 0. As you can see, the datum line coincides with the center line of the pipe. So Z1 that is datum value, height of datum at point 1 is equal to 0, since the pipe coincides with the datum line, and the center line of the pipe coincides with the datum line. Now from the geometry of the pipe, we find that the height of the higher end from the datum line Z2 is equal to 1 over 100 into 300. As the slope is 1 over 100, multiply this by 300, you will get the value of Z2, which is equal to 3 meter. Now we also know that the velocity of water at section 1, V1 is equal to Q divided by A1, as Q is equal to AV or VA, that is discharge area into velocity. Discharge is equal to area into velocity. In this case, discharge is already given, area is already found out, and we have to find the value of V1. So discharge is 0.9 and A1 is 0.1964. So we will put the values and we will get the value of V1, which is equal to 4.58 meter per second. Similarly, find out the value of V2 by putting the value of A2 and discharge 0.9. So you will get the value of V2, which is equal to 1.15 meter per second. Now using the Bernoulli's equation for both the ends of the pipe, so the Bernoulli's equation is Z1 plus V1 square divided by 2G plus P1 divided by omega is equal to Z2 plus P2 square divided by 2G plus P2 divided by omega. So Z1 is already 0, V1 is 4.58, G is 9.81, P1 is to be find out, omega since the liquid is water, so omega, that is unit weight of water, is 9.81, Z2 is 3, V2 is 1.15, G is 9.81, again P2 is already given 70 and omega is 9.81. This is not 981, but this is 9.81. Point is missing from here, so it is 9.81. So simplify this equation, you will get the value of P1, which is equal to 89.7 kilonewton per square meter or 89.7 kilopascal. And this is the answer for example 7.5. Now coming to the next example, example 7.6. The statement of the example is: a pipe 5 meter long is inclined at an angle of 15 degree with the horizontal. The smaller section of the pipe, which is at the lower end, is 80 mm diameter, and the larger section of the pipe is 240 mm diameter as shown in figure. As you can see, the larger diameter is 240 mm and the smaller diameter is 80 mm. The pipe is inclined at an angle of 15 degree with the datum, and the total length of the pipe is 5 meter. Determine the difference of pressure between the two sections if the pipe is uniformly tapering and the velocity of water at the smaller section is 1 meter per second. So we have in this case to find the difference of pressure between these two sections. Also the pipe is uniformly tapering and the velocity of water at the smaller section is given, which is 1 meter per second. So first of all, in solution we will write the given data. In given data, length is given, which is equal to L is equal to 5 meter. Alpha, that is the degree, angle is 15 degree, D1 is 80 mm, that is equal to 0.08 meter, and D2 is equal to 40 mm, which is equal to 0.24 meter, and B1 is 1 meter per second. Now let P1 is equal to pressure at section 1 and P2 is equal to pressure at section 2. Now we know that the area of the pipe at section 1 is equal to A1 is equal to pi by 4 D1 square. Put the value of D1 is equal to 0.08 and we will get the value of A1 which is equal to 5.027 into 10 to the power minus 3 square meter. The area of the pipe at section 2, A2 is equal to pi by 4 D2 square. Put the value of D2 which is 0.24 and you will get the value of A2 which is equal to 45.24 into 10 to the power minus 3 square meter. Now first of all, let us assume that the datum line to coincide with the center of the pipe at section 1 as shown in figure, thus Z1 is equal to 0. Now from the geometry of the pipe we find that the height of the higher end from the datum line Z1 is equal to 0 plus 5 into sine alpha. So 5 sine 15, alpha is 15 degrees, so put the value and you will get the value of Z2 which is 1.294 meter. Since the discharge through the pipe is continuous, therefore using the equation of continuity, A1 V1 is equal to A2 V2, and find the value of V2 which is equal to 0.11 meter per second by putting the values of A1, A2 and V1. Now apply the Bernoulli's equation for both the section of the pipe, that is Z1 plus V1 square divided by 2G plus P1 divided by omega is equal to Z2 plus P2 square divided by 2G plus P2 divided by omega. Put the value of V1 G omega, Z2 V2 G and omega. Put these values and you will get the value of pressure difference P1 minus P2, that is the pressure difference between the 2 points P1 minus P2 is equal to 12.2 kilonewton per square meter or 12.2 kilopascal. And this is the end of our example, or this is the answer for example 7.6. Also this is the end of our today's lecture.